So the next person I'm inviting on the stage is a co-founder at FastNetMon, Pavel Odintsov, and his presentation on BGP FlowSpec for DDoS mitigation, practical aspects.
Hello everyone, thank you for coming. I'm glad to see everyone on my presentation. So I'm Pavel and I'm a founder of a DDoS detection company called FastNetMon. And in general, I'm network security expert and I love internet as many of you. And I believe we share passion about keeping internet alive. And in this presentation, I will tell you about ways how we can actually handle one of the modern threats to existence of internet, which is DDoS attack. For so many years, I would say we have very long history of DDoS attacks, of which counts many decades. We look at DDoS as a persistent thing which was part of our lives, but we all believed that it will disappear. Maybe we can create some tool or maybe some kind of law enforcement or more efficient government work will come handy and then we will eliminate DDoS attack. Unfortunately, it's not happening. And what we can see extraordinary and exponential growth in number of DDoS attack. So on my slide, you can see data provided by a non-for-profit Dutch organization called BalticNOG, and it highlights dynamic of how many attacks we have. You can see we have small reduction of DDoS attack, but again, it's number of attack on scale of hundreds. And just for a single organization, if we extrapolate this number by number of countries we have and by number of organizations, we will easily lead to numbers of millions of attacks, basically, on monthly basis. So DDoS attacks are not going anywhere. But what is the most positive side from my presentation? That most dangerous so-called volumetric attacks are quite simple. And you can see on the right side, top attacks are DNS-based, NTP-based, and the only one which cannot be handled easily, which is HTTP-based. But majority of most dangerous, largest attacks can be address it by using simple tools, and I will tell about what we can do about it. So, what we can do if we are completely not prepared for DDoS attack? You wake up today, your network is down, and your customers are not happy. And the best option what we can do is to use BGP black hole. BGP black hole, I would say, is quite a controversial way to stop DDoS attack, because by the means how it works, we basically unplug internet cable from victim of DDoS attack, which is quite unfortunately aligned with purpose of malicious actors who actually started this attack. But we need to focus on fact that we are network engineers. And we are here to keep network running. And in some cases, we may have to sacrifice one existing customer or part of our network to keep majority of customers is connected to the internet. And in this case, black hole works fine for us. And how BGP black hole works? It works by leveraging on assistance of your upstream operators. You use BGP community, which is standardized to have number 666, to kindly discard all the traffic they receive for your IP address everywhere. And in around 60-90 seconds from time when you deploy this specific rule, you will see complete termination of all traffic worldwide to specific hosts. So by this way, you can handle and stop DDoS attack. It's not proper mitigation because we had to shut down service, which is under attack, but it's just to have more time for us to handle it and handle it properly. What we can do better? Yes. On this diagram, it just looks more complicated. And I especially put more complicated topology of the internet. On previous slide, it was just few routers, but in this case, we have 3 routers, connection to the internet, lots of malicious guys running DDoS attack, and malicious actors. And BGP FlowSpec is a great technology. As the name implies, it's based on BGP, which is widely supported by all telco-grade equipment we have. And second thing is it's standardized. It's not vendor-specific implementation, which will work only on Cisco or only on Juniper. It works on basically every single router, which we consider to be telco-grade. And by saying telco-grade, I'm saying Nokia, Juniper, Cisco, Huawei, Arista, Extreme Networks, all of them have solid support for FlowSpec. How FlowSpec can help you? And FlowSpec is just a way how you can make configuration changes for your firewall in your router. So your router is not only a great router itself, it's also a high efficient firewall which can filter out traffic by specific patterns. You can ask your router to filter out packets of specific protocol, of specific packet lengths. But the only issue in this case, as we basically all operate multi-vendor networks, to do it in the way which will work with majority of your equipment. Instead of just, of course, you can resort to running command line and logging into your router and manually creating a filtering rule. But again, modern DDoS attacks are very fast. They increase in speed from hundreds of megabits to terabits in basically 15 seconds. And if you try to do it manually, no way you can do it in time before actually degradation of your network starts. And what we can do in this case, instead of trying to do it manually, we can leverage some kind of automation which will evaluate attack traffic. And again, majority of DDoS attacks, which are largest, are implemented using protocol UDP. There is a well-known list of ports which are used for amplification attacks. And by deploying some internal automation, you can find out what type of traffic is involved in attack. And majority of cases, it will be following. It will be UDP protocol of these large packets, more than 1,000 bytes, usually coming from port 53 or port 123 or like list of, and usually fragmentation is involved. And then we can use BGP FlowSpec to automatically deploy filtering rules to all your routers. And in case of small networks, it's very easy. Again, you can do it by your own. If you have one router, you can create filtering rule. But if you operate large network, which may count hundreds of routers, it's a challenge. You cannot log into every single of them. And you still need to do it very rapidly. As soon as you see attack, you need to be in position to deploy it in basically less than 1 second to all your locations and all your routers worldwide. And BGP FlowSpec is a perfect protocol to do so. It can help you. And BGP FlowSpec is not new protocol. It's basically 20-year-old protocol. A standard was published in 2009. But there is a fun thing. A company called Juniper worked a very long time on this specific standard. And before standard was actually published, they had existing implementation of it. And FlowSpec is quite, I would say, feature-rich protocol. And you have options to filter out traffic, which is maybe malicious or maybe legitimate, by using basically all the fields available on levels 3 and levels 4 of IP protocol. So you can use source port for filtering, destination port, source prefix, which is also very useful for filtering of modern attack. You can set specific flags. For example, filter out only traffic which uses protocol flag seen in TCP packet. And you can see it's not perfect, but it's limited to capabilities required and which are enough for you to defend most dangerous attacks. A few days before, Cloudflare announced a record-breaking attack of scale 22.3 terabits in capacity. This is crazy capacity, honestly. It's not a capacity which can knock down specific company. It's enough traffic and enough bandwidth to knock down whole countries. It's enormous capacity. But if your network is equipped with modern routers and if you have enough capacity, you can use FlowSpec, this small subset of features of it, to filter out even the most disastrous and world's largest attacks. It's more than enough. And what you can do with BGP FlowSpec in majority of cases, we just want to stop it. Not in all cases it's reasonable because we may have false positives. So you may not be entirely sure that this specific traffic is an attack. Maybe it's malicious, maybe it's not. But there is an safe alternative which allows you, instead of discarding traffic, just to rate limit it. And in this case, it's not only option what you can do with BGP FlowSpec, because BGP FlowSpec, as I presented right now, it's more about way how to make configuration changes for firewall, for distributed firewall. So let's imagine you have 100 routers, you deploy FlowSpec rule to one of them, and then by means of BGP protocol, it will be automatically distributed to all your networks. So you have up-to-date, synchronized firewall on every single location of your network. And the application for DDoS is obvious, but there is a different option what you can do by leveraging on same option. You can use FlowSpec for traffic engineering. So instead of blocking traffic or rate limiting traffic, you can just redirect this traffic to specific equipment or infrastructure allocated for DDoS attack filtering in your network. It may be third-party vendor appliance, or it may be a custom built in part service inside of it, or it may be just servers in your network allocated specifically and optimized specifically to handle DDoS attack. And by this scope, you can look on BGP FlowSpec not only as a way to stop DDoS, but also on way of traffic engineering. But not traffic engineering, which works by moving all traffic of specific host in your network to infrastructure, but more on the more granular way. Because, for example, you can move all traffic which is coming from port 443 via UDP protocol with specific flag set to your filtering infrastructure. And BGP FlowSpec is old protocol. And there is timeline. And you can see committee on IETF spent a long time, as be precise, 6 years to work on BGP FlowSpec protocol. And before it got standardized, Juniper had working implementation. And it's hard to find something which is happened in 2012. And I had to use all options to find out when actually Juniper added this capability. And unfortunately, oldest Juniper version was 12.3. So I was about to say, look, it was created and published in 2012. Not correct. It was in 2005. And I spent quite a lot of time to find out changelog for Juniper release, of specific version of Juniper release. And I found it, I got it copy, and it didn't mention BGP FlowSpec. The reason is simple. It was technical preview. It was created by request of one of their largest customers, and it was not mentioned in official Junos changelog because it was early implementation, it wasn't standardized, it was think to try. But you see, it was implemented in 2005. And sometimes people tell BGP FlowSpec is a new protocol, and now we have 20-year-old protocol, which is present in basically all the routers we have, which is mature, which is stable. And in terms of deployments, I can tell you that 60% of tier 1 carriers, they do have BGP FlowSpec on their network. And from this point, I need to provide a little bit clarity. What does it mean to have FlowSpec on network? You may use it for your purposes. For example, for purposes of traffic engineering or for purposes of defense operator itself. But in some cases, you may use and may provide it to your customers. And second option is very rare, but still, for example, Hurricane Electric and Telecom Italy, they do have options to provide FlowSpec for you as a customer. And then, by having access to FlowSpec, instead of filtering all the capacity of modern attacks on your infrastructure, you may leverage their capacity, which is way higher, even if it's limited to their point of presence. to filter out DDoS attack. So, and Juniper was the first company to implement FlowSpec support. Then it was followed by Nokia, which was Alcatel-Lucent by time. Then followed by Cisco. It's a poor mystery for me why Cisco spent so long time to implement it, because Cisco engineers weren't involved in early work on standard, but still they waited for a long time before implementing it. But when they actually implemented it, it worked just fine, and we had no complaints and operational issues with Cisco's FlowSpec implementation. And if we are talking about more developer-friendly solutions, it's GoBGP. It also supports BGP FlowSpec. And GoBGP is very important in this case. Why? Because to deploy BGP FlowSpec rules, you need to have tool to do so. And you cannot create FlowSpec annons from command line. I mean, on some vendors you can, but it's not reasonable. Instead, what usually customers do is they allocate specific machine and they deploy BGP speaker, which is being used as route injector. So they create BGP FlowSpec annons. They maintain BGP FlowSpec enabled sessions with all their routers in infrastructure. And GoBGP is perfect for this task. So you can create BGP FlowSpec annons in command line, and then it will be distributed to all your routers in your network. And finally, BIRD 2017. And as usual, we live in the real world, and unfortunately, vendor implementation is going with string attached. So what I have shown you on first slide, what kind of capabilities we have in FlowSpec that we can filter out by router, or by packet lengths, by specific flags. There are limitations which are vendor specific, and usually they influenced by hardware, as in the case of Extreme. And they had, I would say, issues for way how they handle different flags. So for example, if you use some very rare flags in TCP, like flag of urgency or a reserved flag, there is an option in FlowSpec protocol to set them. But if you set them and send this kind of announce to Extreme, it will just ignore them, because for some reasons they did not like it and they did not implement it. So, and one of the latest additions in the portfolio of BGP FlowSpec capable routers was Arista, is 2020. And I would say Arista is one of the most dynamic vendors in this way, because we had lots of complaints about their implementation. When they presented their very first implementation of FlowSpec, it has 12 items in list of constraints and limitations. By time being, they eliminated all of them. And I would say we can declare that their implementation of FlowSpec is complete and mature and can be used for even largest networks, and with, of course with production grade quality. And everything coming with challenges. And everything looks perfect when we look on standards, but as soon as we start operating it, we get into problems. And those problems are very hard to consider during design phase of designing of protocol. And in case of BGP FlowSpec, we have some list of, I would say, minor constraints which limit your options to use FlowSpec. But I cannot say they're critical. They're more vendor specific. And what we can see globally is that adoption of BGP FlowSpec protocol is growing. More tier 2 providers are added in their portfolio for their internal network protection. More tier 1 providers add support, and it's dynamic process. It's actively evolving protocol, and there is an actually development for a protocol called BGP FlowSpec 2. It's a draft, and it's hard to say what it will be about, but there are some complaints about what we have and what we don't have in BGP FlowSpec. An idea of a work group which works on BGP FlowSpec to actually find out and provide improved version of protocol, which will allow us not only filter traffic by specific fields, like filter traffic which has length 500, or filter traffic from port 53, but provide it more dynamic. Let's imagine filter all traffic which has byte set to 15, by shift from start of packet 25 bytes. And by doing so, we can enhance our filtering capabilities, not be limited by standard protocols like UDP or TCP. We can add new protocols, for example, implement filtering by fields in header of quick protocol, or add support for VXLAN filtering, or support for MPLS traffic. So there are lots of options how it can be improved. And you can see if you invest right now into using BGP, in deploying BGP FlowSpec for your network, you may be well prepared for future generation of this protocol, because all the networks, if they want to survive and they want to address modern threats of DDoS attacks, they have to implement FlowSpec for their own purposes or for their customers. It doesn't matter, but you still need to consider it and at least deploy it for your network. And there is a list of limitations in BGP FlowSpec protocol, and a few of them I would like to mention explicitly. And most, I would say, annoying issue for us is from Juniper MX series. The problem in this case is that when we filter out something, let's imagine we have ongoing DDoS attack of scale hundreds gigabits, and then we find out what was pattern of traffic which was involved in DDoS attack. Then we create FlowSpec rule and filter out all malicious traffic. But what we want to see how efficiently our filtering works. So on our graphs of our network, which will show us how much traffic we have in total, we want to see how much traffic actually was filtered. And in Juniper, it's very hard to get this information from NetFlow or IPFIX telemetry. So their logic to encode this knowledge, I would say, to find out that this specific flow was discarded or not, is one of the most complicated we ever seen from all the vendors. Cisco ASR 900, I would say it's quite minor concern. It's mostly hardware influenced, and in modern generation of Cisco 9000, it should not be your problem, but still it's worth to mention. It's just one of the ways how their engineers interpreted standard. So they just for some reasons in standard it was option to use two different ways how TCP flags can be encoded, in 1 byte or 2 bytes. And some vendors decided to support one of them, and a different vendor decided to pick up alternative one. And for us, as implementers of BGP FlowSpec protocol, we basically need to consider and we need to test it. And what is most important, if you decide to deploy FlowSpec on your network, you have to carefully test it. All the options, filtering by source port, destination port, by packet length, by flags, but everything, you have to be sure that your equipment works exactly as expected. So you deploy a rule, you can see, you simulate traffic, you can see the traffic is discarded. Because BGP FlowSpec is very complex. And every single time when you deploy BGP FlowSpec rule to your equipment, lots of magic happens inside. And due to hardware limitation, you may have side effects. You may have bugs in your software. You may have bugs in your hardware. And to be 100% sure in your FlowSpec deployment for your network, you have to test it all the time because it's really complex protocol. If we look on BGP protocol as itself, it's a relatively simple protocol. It's an LRI, prefix length, type of announce, and still lots of issues were discovered over past years. For example, issues with attribute encoding in many vendors. And FlowSpec is 100 times more complicated from protocol perspective than regular BGP unicast. And we need to keep it in mind. There are lots of bugs which were fixed and addressed by times of existence of this protocol. So 20 years is a long time, but still we may have new bugs, and you need to be very careful when you deploy new equipment, just to be sure that this specific flag will be deployed correctly. One of the major concerns and major, I would say, issues we had with BGP FlowSpec from our customers is way how routers they work with fragmentation flag. Why it's most important? Because majority of the DDoS attacks are coming via fragmented UDP traffic. And we need to encode in special way that please the router, please filter out all the traffic which is coming via protocol UDP, and it's fragmented. And many vendors actually behave very unexpectedly in those cases. Some vendors, when we explicitly ask them to filter out fragmented traffic, they just ignore it. Some vendors pretend to accept rule, but just let it pass. Some vendors just ignore our rule and don't install it in a local routing table. And that's why it's very important to look why and what happens, at least to check most obvious cases, just to be sure that in case when your network receives huge DDoS attack, and when you deploy countermeasures by deploying FlowSpec rule to every site of your network, you will be sure that it will be filtered. But in the same time, you need to have decent visibility in your network to understand which traffic is coming and free flowing into your network and which one is being discarded by FlowSpec rules on your edge. So there are limitations, and I can recommend you to check my slides. They're minor, and again, Arista is one of the examples which did not work well with isFragment flag, which was quite shocking to find out, because unfortunately it was found by our customer during real ongoing DDoS attack because they deployed rule, but it did not stop anything. And it's more I would like to highlight more importance of having network visibility in place. You need to understand which traffic is normal for your network and when you deploy BGP FlowSpec rules, you need to understand that this traffic is actually filtering out, not just letting through. And Extreme. And Extreme Networks was actually latest company to introduce BGP FlowSpec support, and I would not blame them, but still it's quite long list of limitations, and one of them annoys me a lot, and because it's lack of IPv6 support, so which is quite controversial in modern age. But still, we can see with every single release of Extreme Network EOS, we can see improvements, and this list of limitations and constraints in FlowSpec getting shorter and shorter because more and more companies actually put FlowSpec as part of their requirement for vendor. And if you're looking forward, I would recommend to personally to add it as part of requirements from vendor as condition to buy their equipment, because it's exactly same as require IPv6 support for new equipment, exactly same to ask for FlowSpec support. If you have no reasons and you have no intention to use it right now, I would recommend to add it because it doesn't hurt and it will more communicate to vendors about the importance of it, and very likely you will need it. So, and that's all. Thank you for listening, and I will be happy to answer your questions, and I will be happy to share our field experience with BGP FlowSpec. We do our best to communicate with vendors. We do our best to communicate with standardizing committees of IETF to make integration and operation of FlowSpec less painful for everyone. Thank you.
Thank you, Pavel. Do we have any questions in the audience? Go ahead. We'll just get you a mic real quick.
Hello. From our experience, Hurricane Electrics and Retina support FlowSpec as a provider to their customers, but not many others that we experience. I was wondering if you know more providers that provide FlowSpec support to their customers, and if not, why is it that providers do not provide this feature to their customers?
From list of companies, I also heard that Telecom Italy has support for it. It depends on region. I also heard that Core Backbone has support for BGP FlowSpec. And I would like to highlight the reason why not so many companies actually offer BGP FlowSpec. One of the major issues for Tier 2 and Tier 1 providers for FlowSpec, it's complexity of FlowSpec rule. Because for equipment is in FlowSpec, you can create ACL rule, for example, which may list hundreds of ports. So you want to filter out all BGP traffic which is coming from a long list of ports. And for equipment, it's just single row. For us, it's just single row. But for equipment, it may unfold into 100 rows and hypothetically may overload equipment of operator. And from what I know from one of the company you just mentioned, they have custom solution which actually validates BGP FlowSpec annonces, applies their own constraints. Let's imagine, don't put more than 50 ports, don't put filters by flags in TCP packet. And only after that, they also apply a limit about number of rules you can inject. And actually, what I heard, some companies actually charge you on per rule basis how many rules you can actually deploy. And usually you're complaining by 10 or like 20 rules you can deploy it, because just to keep infrastructure of operator itself running. And but bright side of it, there are solutions for it. There are solutions for validation. I heard some solutions. Actually, one of the companies I didn't mention, it's called Rascom. They use XBGP based solution for incoming FlowSpec rule validation, and they also can offer it for customers. And honestly, I would love to see more companies and tier 1 or tier 2 operators offering it at least as an option, at least as a paid option, because for what is a great advantage of BGP FlowSpec is that if you can leverage and ask your upstream to assist you in filtering out malicious attack, which may be 100 gigabits or terabit, basically you eliminate any need to rely on third-party services for attack mitigation. You don't need to pay some commercial companies. You don't need to pay specialized for specialized equipment. You can defend from DDoS attack on your own, basically with assistance of your ISP. And I hope in future it will be more widespread, as we have, for example, BGP Blackhole is a standard for majority of worldwide networks. And I hope at some point of time BGP FlowSpec also will be standard offering as part of telecom service.
Thank you. Okay, so in case you have, okay,
yep,
quickly.
Yep. Quick last one. So I just wanted to comment on this question and answer. So I work for Nokia, right? And I can probably give a hint on why most operators don't allow you to use FlowSpec. You mentioned validation, which is one thing, but you can do that on software, so that should be easy to fix. But then there's the hardware scale. So on Nokia routers, you can install up to 256,000 filter entries, which is a fair number. On Juniper, if there's any Juniper folk here, can confirm, I think it's 64,000, which is 4 times less, but still pretty good number. But on some of the devices that you showed in your presentations, these numbers are very low, like 1,000, 2,000 filter entries. If you compare it to 256,000, there's a huge difference. Now imagine if you have, I don't know, a few hundreds or even thousands of customers around the world wanting to install filters, then you will fill up, this memory. So that's the reason why most of them don't provide this capability, because depending on the vendor, the scale of the filter entries is pretty low, right? So that's one.
Thank you. I do feel like there's going to be an interesting discussion, so I encourage you to meet up during the break.
Thank you for a great question.
If you want to talk. Thank you. And
thank you for listening.
No worries.